Anong reaction niyo nung nakita niyo yung score niyo sa midterm? Napawawa kayo. Ina-expect niyo bang ganun? Or merong nag-expect sa inyo na mas mataas yung nakuha niyo? Yes. Picture muna tayo. Ang highest, gusto niyo malaman ko kung anong score ng highest? Ang highest, ay wait, open ka lang. Nakalimutan ko. Open cam na po yung iba. O si RM kakagising lang talaga eh. Mumukat-mukat pa eh. Ago. Ago. Ano ba ngayon? November 9. Okay. November 9. Okay. Swan, anong post natin? Amute ka, Swan.
Ano po yun, sir?
Anong post natin? Anong gusto mong post natin?
Kahit ano, sir.
Ikaw ka ang pipili. Kalyo ko mo ka. O, ganun daw, ganun daw. Hiyang-hiya siya eh. O, ganun daw. Panindigan mo na, Swan. Picture. Ang hindi nakapisign absent. Okay. 1, 2, 3. Mga pauso. Lagi na. Wait lang. 2024 attendance 12 November 9. Okay. Thank you. Save ko na. Ang naka-highest sa midterm is 17. So, tatlo sila. Sino kaya yun? Sino malaman? I-chat ko sa chat box. Ang lowest natin ay 6. And isipin nyo na lang guys, 5 yung bonus points natin. So, ang tunay na highest is 12. And ang tunay na lowest is 1. So, kung bakit 5 yung bonus points doon, diniscuss ko naman kung ano yung sagot sa midterm natin noon. And, huwag nyo na like kalat. Kasi bukas, oo nga no. Bukas, kasi bala ko ibalik yung exam. Magkikita tayo bukas, di ba? Bukas yun, di ba?
Opo.
Hindi pa kayo bayad. Sir, mas mataas na kayo. Magkano singil ko dun? Ano sabi ko, Lucel? 5 pesos lang, no?
9 pesos po, sir.
9? Ba't dinagdagan mo na agad? Grabe ka naman, Lucel.
Sir, sabi niyo po 9. Nasa akin po pala ang payment. Ay, hindi pa po tayo nagkikita, kaya di ko po nabibigay.
Siningil kayo na 9 pesos? Sabi ko kay Lucel, 5 pesos lang. Grabe naman yan. Joke. Paano outlook ngayon dito? Parang gusto ko kayo i-mindset ba? Kasi, truthfully speaking, hindi naman ibig sabihin na ganun ang score sa midterm is babagsak na. Kasi kung maalala nyo sa syllabus natin, mas malaki ang bearing ng design project tsaka design plate. Kaya ang lagi kong inuulit, ang bumagsak lang sa akin nun is yung mga hindi nagpapasa ng design plate. And maganda, kailangan kumpleto kayo lagi doon. Then sa design project, I hope may movement na kayo. Kasi di ba last meeting, nung Sunday, diniscuss ko na sa inyo yung ating calendar. So dapat pagdating ng December 1, is ready na kayo mag-present. Unfortunately, online tayo. Wala tayong magawa. Mas maganda sana kung harapan yun eh. Pero, nandito pa rin naman ako sa school nun. So, yun lang. Then for today, ay CAM analytical method tayo. Mahirap tong topic na to. Sabihin ko na sa inyo, super hirap nito. Kasama ba sa exam? Oo eh. Wala nang madali sa panahon ngayon talaga. Wait, in-upload ko na ba to? Oo. CAM 5.3, CAM analytical method. Wait, may download lang akong file. Ano tayo download? Hello, ba't yun? Ayun. Okay. So, dito sa atin, sa CAM analytical method, mas mahirap to eh. Kaysa dun sa last na meeting natin na topic. Wait lang. Kailan ba tayo last nag-meet? November 3. 27. Wait lang ha. Yes, sa analytical method, may we have computations, pero hindi naman natin sasauluhin yung formulas. Dahil i-share screen ko lang yung mga formula. So dito, ito are kung sa graphical method, meron tayong apat na curve, which is the parabolic constant acceleration deceleration, the parabolic constant velocity, the simple harmonic motion, and the cycloidal motion. Dito sa atin sa analytical method, we have three motions, which is the cycloidal motion. So meron pa din tayong cycloidal. we have harmonic. So, this yung simple harmonic motion and the 8-power polynomial. So what we will do here is this table will be given to you during exam. So you don't have to memorize these formulas. So let's just take a closer look. Okay. S is for the displacement. V is for velocity. And A is for acceleration. So meaning, for cycloidal motion, we have 6 different curves for each motion. So we have the motion for displacement, velocity, and acceleration. We have 6 choices. Yeah. Then, we have to design the curve based on these templates. During exam, I will just be giving you what kind of motion, then you will choose which among these you will use. So if, for example, using analytical method and we have a cycloidal motion, you will select from these 6, C1, C2, C3, C4, C5, and C6. Which among these 6 will you use depending on the requirement? So the formulas are all different from each other. So let's analyze the formulas. We have L, which is the lift, and this lift will be used in this computation. We have 2 types of angle, the angle beta and theta. It will also be used here in the computations. So here, we don't have to convert to radians, the angles, because it is used in the sine function. And here, on theta over beta, even if we convert it to radians, it will only cancel out. So no need to convert here. Then, for this one, I think no need to convert also, even if it's divided by the length. These are all derived formulas. So, kung paano to nagawa, I don't know. Si Klumuk and Mapli, yan, siya nagpapahirap sa buhay natin. Pero anyway, this is the cam displacement curve for that. The difference here is, example for the displacement, in the previous approach or the previous method that I taught you, we will be using a cam displacement curve, and in the curve, we will measure the height from the x-axis, which we will copy to our base circle to compute for the displacement. But here in analytical method, it is computed. Meaning, for a given angle, here the angles are given. For the given angle, there will be a definite answer for the displacement. So, kung ano yung answer dito, yun yung ilalagay sa base circle. So, kinompute. Hindi kagaya dito sa graphical method, not like the graphical method that we used last week and last week. What we did was, we make the curves and we just measure the distances from the x-axis to the curves. So that's the difference on that. So using this analytical method, we will have a more precise cam displacement curve. And for velocity, this is only for reference, because on the analytical method, in the graphical method, we did not compute for velocity and acceleration, which is, it's okay. Velocity and acceleration can only be computed using analytical method, so not graphical method. So on graphical method, we only have displacement, become displacement curve, and in analytical method, we have velocity and acceleration. So again, depending on the requirement on the problem, you will have to choose among these C1 hanggang C6, which you will use, which formula you will use, and which curve you will use. Same with harmonic. So harmonic has 6 types of curves also for displacement, velocity, and acceleration. Depending on the problem, which we will use. So later on, I will give you a sample problem for you to see how it is applied. Then for 8 power polynomial is there are only 2 choices which we will use for this. What's key or what's a hint for using this is when starting a motion, our starting motion will definitely always start at 0. So in looking at these curves, which curve starts at 0? So we have C1, C2, not C4, C5, yeah, only these 3. So if the given problem says the cam and follower motion starts with a cycloidal motion, we will only use among these. We will only select among these 3. If the problem states that design for a cam which starts with harmonic motion, so let's look for motions of harmonic that starts from 0. So like also this one, H1, H2, H5. So how about the others? Because the motion of the cams can be a combination of the motions. So the combination, for example, it starts with cycloidal, then it proceeds with harmonic. So if you were gonna select, you have to match these shapes with the other. So again, if it starts with cycloidal and the following motion is harmonic, let's look at the curves. So we can, if it starts with cycloidal, we can use C1, C2, and C5 because it all starts from 0. Then, let's look at harmonic. Which of these curves can we connect with C1? So for C1, we have the displacement curve from 0 going upwards. For harmonic, which among these can we connect to C1 to have a harmonic motion? So for displacement, we can't use H1 because look at the curve. If we will use C1, it's a curve going up. While the curve of S1 at H1 cannot continue a fluid curve. If we will partner this C1 with H1, it will not make a fluid curve. So we cannot use H1. For H2, we can use this because looking at the curve of S, C1, it goes up and it can be continued here at H2. So this one is S1, C1. So we can make that. Let's check about the others. For H3, we cannot use the displacement because the curve is from, if we connect this to the S curve of C1, it will not make a fluid motion. So the motion of the displacement of C1 is going up. So if we will connect it with H3, it does not make a fluid motion. Then for H4 also we cannot use H4 because it does not have a fluid motion. The curve at C1 is going up like this, so it will not make a fluid motion here. For H5 also, we cannot use it because the motion is different. So the movement of H5 does not make a fluid motion connection with C1. Then for H6, it cannot also make a fluid motion, not a continuous curve. So we only have H1. H2 pala. Yeah. So let's delete this. Then let's look at the velocity. So to make a match, once we have matched the displacement, the curve, let's look at the velocity. So the velocity at C1 is from 0 going up, and if we will connect it to H2, it can make a fluid curve. So it's going up, then going down. So they're a match. Then for acceleration, the acceleration at cycloidal motion goes up, then it goes down, so it goes back to the x-axis. While the acceleration of H2 starts from the x-axis. So they can be connected also. Okay? So don't be confused that since in the drawing, the displacement starts from 0, it does not mean that the succeeding motions must also start from 0. So if we have two motions, if given, for example, cycloidal, then the next motion is harmonic, only the cycloidal should start from the x-axis. While the other motions can be connected to the motion of the previous one, even if it looks like here that it starts with x-axis, we can still use it because it only depends on the first one who will start the x-axis. The curve must be followed. Very confusing. So again, for the succeeding motions, it does not have to start with the x-axis, only the first one. But the curve must be maintained. So this one, if we have a sample that the harmonic motion is followed from cycloidal motion, we will start with the cycloidal motion that starts with the x-axis. Then, regardless of the curves, if it starts with x-axis or not, when connected to the previous motion, it must make a fluid curve. So here we found that C1 and H2 can be connected. Then, to close out the motion, we need to go back to the x-axis. So if you can remember in the graphical analysis or the graphical method of cam displacement, the cam displacement curve starts from 0 and it ends in 0 also. So if we will look at the harmonic, it ends on height, on displacement. The velocity ends at 0, but the acceleration does not end here. So if we will have, for example, an 8-power polynomial motion, to end the motion, let's look on what curves here can connect that will end with 0. So for H2, we can connect it with P2 because the displacement curve of H2 can be connected here to make a fluid curve. For velocity, since the velocity is going down to zero, we can connect it also to the velocity of t2. Then for acceleration, since it is going here, going down, we can connect it also to p2, which is starts with below the x-axis and it ends with x-axis. So all of this ends in x-axis. I will have a better graphical explanation for this, but for now, that's the concept. So again, the concept is when given the motions on the design problem, we will have to select which among these curves we will combine to achieve the required motion. So if the required motion is, it starts with cycloidal, followed by harmonic, and ends in 8 power polynomial, we can use C1, H2, and P2 as the combination. Okay, so that's the graphical analysis, the analytical analysis of cam displacement. Okay, I will show you the much thorough explanation for this one. This will be part of the final exam. There will be design problem consideration, and you will have to select among the given formulas which you will use. Okay. For cam displacement curve on analytical method, we have the Klumuk and Muffley here. We have the formulas here. I made this presentation a step-by-step procedure so you can follow it by studying it yourself. Then, its application, how do we use it? So, for example, this is the given design consideration. The cam profile is defined by the combination of the motion curve as follows. It starts with 8-degree polynomial, then followed by harmonic motion, then ending at cycloidal motion. The total lift is 70 mm. So the lift is given. If the design will not allow any sudden change in acceleration value and the lift return in the harmonic cycloidal and the lift and return in the harmonic and cycloidal portion is 35 mm each, determine the following. What does it mean? Let's analyze first the problem. First, it is given that the motion is started by 8-degree polynomial motion, or what's it called? 8-degree or 8 power. It's the same thing. So 8 power polynomial, 8-degree polynomial, it's the same. Then, the total lift is 70 mm, but there's another lift given which is 35 mm. Meaning, for the computations for the analytical method on the harmonic part and the cycloidal part, our lift that we will use is only 35. But for the 8-degree polynomial, we will use 70. So meaning during the 8-degree polynomial, it will reach 70, while on the harmonic and cycloidal motion, it will only reach 35. Define each of the motion curves to be used and plot the SVA curves. Again, SVA is displacement, velocity, and acceleration. So, ba't hindi D? No? Displacement, hindi dapat D. Ewan ko. Pauso nila yun eh. The velocity is V, acceleration is A, but S is displacement. Ewan ko bakit. Again, when we say define each of the motion curves, we will have to select which among the choices of the curves we will use. Then plot the SVA curves. So when plotting the SVA curves, um, we don't have to be exact. We just have to copy the motion curve. So how do we do that? So first, let's look again on the table made by uh, Kumuk and Mafli. So here on the given, it's 8 degree, but it's also the same with 8 power polynomial. So just it's the same thing. So the given, we start with 8 power polynomial, then followed by harmonic motion, and then cycloidal motion. So for the 8 power polynomial, there are only two choices. And one is obviously the selection because P1 starts from 0. We can see here on the displacement, velocity, and acceleration. On P2, though velocity starts from 0, but the displacement does not start from 0. So we cannot use P2 when we are going to start with 8-degree polynomial. So we have now P1. Then for harmonic, we will have to look on the curves at the 8 power polynomial. And let's make a closer look. So here on the displacement curve, it is from 0 going to the high side, which is L. Then it will be followed by a harmonic motion. So the harmonic motion, which among these curves can we use that will not make a sudden change in acceleration and velocity? So if you will go back to the problem, the term here will not allow any sudden change in acceleration value, meaning the curves must be fluid. So what curve can we connect to the displacement from the harmonic motion? So what we will do here is check one by one which motion is fitted. So for the displacement, H1 can be used because the curve here is going up like that. So we can connect here the motion going up. So again, even though the following curve starts from 0, it does not mean that it will go to 0. It only applies for the first motion. So we can use h1 on the displacement curve. Now let's look at the velocity. The velocity starts from 0 and make an arc like this. But if you will connect it to the velocity of P1, it does not make a smooth curve. So let's not use this. How about H2? So H2, we have a curve going like this. But if we connect it to the curve here at 8 power polynomial at P1, it does not make a smooth curve. So if you will apply here like that, so it does not make a smooth curve. So we cannot use H2. So even if one does not fit the previous motion, it is already disregarded. Then how about H3? So H3, we can use the displacement curve because it if when connected to the displacement curve at the first motion, it can make a smooth curve. So this can be used. Then for velocity curve, it starts from 0, then goes up, then goes down. And if we connect it to H3, it can also make a smooth curve. So we can use H3. Then for acceleration, it starts, the polynomial ends at below the x-axis. So H3 starts from below the x-axis also. So we can also connect it here. So if we will use H3, wait lang. Sama. Sama. So we can use H3 here to determine the curve. Then, starting from H3 is, we will now select from the cycloidal motion. So for the cycloidal motion, which among these curves can we use that will end at 0? So for H1, for C1, we cannot connect C1, the displacement curve, we cannot connect to H3 because it does not make a fluid curve. So this is not an option. For C2, we cannot also connect to the displacement curve. So not also an option. For C3, it's the same thing. We cannot connect here because it will not make a fluid curve. So for C4, ay, ano ba yan? Ayoko na magkaubo. For C4, if you will look at the motion, the curve at S points going downwards and can be connected to C4. So we can use this. Then looking at the velocity curve, it starts from below the x-axis and the H3 ended below the x-axis. So we can use C4. Then lastly, for the acceleration stop at x-axis, and we can also, and the acceleration at C4 starts and ends in x-axis. So we can use C4. So that's just the way of selecting which curves we will use. Because once we have selected the curves, it's also the same thing as selecting the formulas we will use. So for this one, since we selected P1, this is the formulas that we will use for displacement, for velocity, and for acceleration. Okay. So these are the motions that we have selected: P1, H3, and C4. What we will do now is we will make a rough sketch on how it would look like if we connect all the curves. So we will connect the displacement. We will draw by hand on how it would look like, just a rough sketch for the velocity and the acceleration. So for the displacement, it will look like something like this. And again, since the harmonic motion is not the ending motion, it does not have to look like it ends at the x-axis. So that's why here, when we connect it, we will start with the 8-degree polynomial. So this one. Then the harmonic motion goes down and is then connected to the cycloidal motion. The cam displacement curve will look something like this here below. So again, we don't have to measure it. We'll just have to make a rough sketch on how it would look like when we trace it. So let's just combine these three curves, drawing it by hand to show that we use these three curves. Then for velocity, the curves look something like this for the polynomial, the harmonic, and the cycloidal. So when we, and on the acceleration, the curves looks something like this. So when we sketch it, when we answer item number 1, when it says define the curves, we will have to select the P1, H3, and C4. Then we will make a rough sketch of the curves. So again, for the analytical method, the first step is to understand the problem. Then the motion are given. It starts with polynomial, 8-power polynomial, then followed by harmonic, then followed by cycloidal. Then we'll have to select from the table by Klumuk and Mafli which curves will connect with each other considering the given motions. Then you will have to draw a representation of these motions. The curves does not have to have any exact measurement. We'll just have to grab the concept. So just like this, just a rough sketch will be okay. So that's how you select. Now, once we have selected the motions, it is understood that these three motions is one complete rotation of the it is a one complete rotation of the cam, meaning the distribution of angles for these three motions when added up, it is 360 degrees. So again, if given this three motion, it is assumed that this three motion is for the whole rotation of the cam. And one rotation is 360 degrees. Meaning, the division of these three motions when added up is equal to 360 degrees. And if you can recall on the formulas for each motion, there is a beta. So we will have to compute for the beta for each motion. So it is not given how much rotation angle for the polynomial, the harmonic, and the cycloidal. Let's see how to compute for that. So to compute for the beta, we will assume that the theta is equal to beta at first. So at the first motion, the polynomial motion, the acceleration formula is, just look at the first part first here. The polynomial motion, the computation for the acceleration is this long formula. Again, you will not have to memorize this because it will be given on the as part of the attachments of the exam. For the first motion, we can assume that theta is equal to beta. So what we will do is cancel this and have it as 1 because they are equal. So all here in the parentheses are now 1. then L over 1 squared. Then we will have to compute for that. Then for the harmonic motion, the acceleration is of the theta is equal to 0, because if you can see here, the motion ends at 0. And this is theta, and it's at 0. So that's why theta is equal to 0. Then, if we substitute it here, we will have an answer also. At the 8 power polynomial, where L is equal to 70, so this one, and B1 is equal to theta, so this one is 0. This is 1. It will cancel out as 1. Then here, if the theta is 0, we will have an acceleration here. Then we will equate this one. So again, once we have computed for the acceleration, because it is also given that it will not allow any sudden change in acceleration, meaning the acceleration of these two is equal. So the acceleration for the polynomial, 8 power polynomial, is equated to the acceleration of the harmonic. So we will now equate these two, and we will have two variables, the beta 1 and beta 2. And if we will simplify this will be the relationship now. Beta 2 is equal to 0.483 beta 1. Again, what we did here is we copied the formula. Then, assuming that beta 1 is equal to theta, because this is the first motion, this will be cancelled to 1. Then, we have here theta is equal to 0, because again of this curve, it ended with 0. Then, given that the lift is 35 mm at the harmonic motion, we will have beta 2 here as the last remaining variable. And we will equate these two accelerations because it is given that there is no change in acceleration. And we will now have a relationship of this one. Beta 2 is equal to, after simplifying these equations. So let's just park this relationship and let's go to the other. So again, to determine the others, we can match the velocities also, because since the acceleration has not changed, and then also the velocity. We have formulas for the velocity at harmonic and cycloidal motion. We can use this one as reference. We'll just have to match these two. Then, having the lift at 35, and here theta is again 0 because the velocity ended here at 0 theta. Then, theta over B2 is again 1. Then, this is 0. We will have, when we equate this one with this one, we will now have the relationship of beta 3 is equal to 4 over pi beta 2. So if we simplify this equation, we will have this relationship. Then once we have this relationship, we now have three formulas that involve the beta 1, 2, and 3. So we have computed B2, by equating the accelerations of the cycloidal, the harmonic and the polynomial. Then we have B3 and B2 from the velocity of harmonic and cycloidal. Then we have B1, B2, B3 is equal to 360. So here, you can use any match. So if you want to match the acceleration of harmonic and cycloidal, it's okay. I just made an example here that which we can use. If you want to match the velocities of polynomial and harmonic, can also be used. So now we have these three working equations, and if we use a substitution method, we will arrive to determine that the total of this is the angle is 171, 82, and 106. So I just made a shortcut here. So if you will see here, if beta 2 is equal to beta 1, we can substitute it here. And this one, we can substitute it here on B3. And on B2, we can substitute it here on B2. So we will have beta 1 only. Then we can compute. We will arrive at 171. Then for beta 2, we will have 82. And for beta 3, we will have 106. So for the computation of this one, I would like it also to have in whole numbers. So now we have computed here. If we will go back to our cam displacement curve, it only means on the polynomial part, we have 171 degrees of cam rotation. For the harmonic part, we have 82 degrees of cam rotation. And for the cycloidal part, we have 106 degrees of cam rotation. We have now drawn the cam displacement curve. Then, the next item here is determine the lift when cam angle rotation is 90 degrees. So the first step here is first to identify which part of the cam rotation does 90 degrees belong to. If we go back to these computed values of the beta, we see that the polynomial part is up to 171 degrees. Meaning, if we were to determine the lift at 90 degrees, it is still within the 8 power polynomial motion. So we will use the formulas for displacement in the 8 power polynomial motion. So the displacement formula for the 8 power polynomial motion is this one. And what we will do is, given the data, which is 90 degrees, given the total lift L is 70, given that the beta at the polynomial is 171, we can compute for S. So all the variables are given. The others are computed. So the variable L, 70 is given. The angle 90 is given, the data. Then 171 is the computed value of beta. So we will now have to substitute this only to this one. We will substitute 90 to all the data. Then the 171, substitute to all the beta. And once we have substituted everything, we can compute now for the lift, which gives us an answer of 33 point something. So we'll just have to copy these formulas here. Again, you don't have to memorize these formulas. It only looks intimidating because it has a lot of decimals. But it's only as simple as calc techniques. So calculator techniques only to compute for this one. And we will now have the lift. Then for the last item, determine the lift when the cam angle rotation is 270. So again, going back to the motions, we have 8-degree polynomial, we have harmonic and cycloidal. We have 171 here, we have 81 here, and if we total these two, it is 252. But if we're talking about 270, meaning it is within the cycloidal motion. So if we were to determine the lift at 270 degrees, we will have to look at the formulas at the cycloidal motion. So computing for the lift at the cycloidal motion, this is the extracted formula. What's different here is if when computing, we will not use 270 here at the theta. Because earlier, the given 90 degrees is directly substituted to the formula. Because 270 is already the third motion. So what we will do is we have to subtract the preceding or the previous motions from the given. So the given is 270 and the angle at the 8th power polynomial is 171 and the angle for the harmonic motion is 81. So the answer here is 99, 81, 18, around 18. Then this will be the one to be used here on the angle theta. Then on the beta, since it given is 106, 82 pala to. Nakalagay na pala doon. So this is 17. Then the beta is given at 106. So we'll just substitute it to the formula. And now we'll just simply compute the lift. And the lift here is 35 because at the given formula, the maximum lift for the harmonic and cycloidal motion is only 35. So we will have an answer of 24. Using this analytical method, using this formula, we can have a more specific lift computation. We can have a more specific cam profile by using this analytical method. Okay, so that's it. I'll just make a recap, then class dismiss. Favorite. Again, this is already uploaded in our Google Classroom. Then you can revisit it. It will be part of the final exam, so you can practice it at home. For cam displacement curve analytical method, we will have to refer on this table of formulas and curves, which is made by Klumuk and Mafli. So what we will do is, when given the design problem, is we will have to connect curves that will satisfy the given motions. So for example, we are given with the motion that will start with 8-degree polynomial, then followed by harmonic and cycloidal, we will have to look at the curves. So which among these we will use to connect the curves with each other. So when starting a motion, if you can remember in the graphical method, we always start with 0. So if the choices for the 8 power polynomial is just these two, which among these P1 and P2 will we use? We will use P1 because P1 the curves starts from 0. Then for the motion in the middle, it does not necessarily mean that it starts and ends with 0. But the last motion must end with 0. So if we will look for the harmonic motion, which among these curves can connect to P1, that there will be no abrupt change in acceleration or velocity. So, ibig sabihin lang dito, ano yung pwede natin i-connect na curves dito sa P1 na magkakaroon lang siya ng smooth na curve. So, here we can use H3 because if we connect the curve of H3 to the displacement of the P1, it will make a smooth curve. If we connect it to the velocities, it will also make a smooth curve and also with the acceleration. Then, using H3, we will now have to select the curves for the following motion, which is cycloidal motion. And among this cycloidal motion, we have determined C4 on which we can use. Because cycloidal motion is the last motion, we will have to select motion curves that ends at 0. So we have C4 and C6, only these two. Because C1, the displacement does not end at 0, although C3's curve ends with 0, but the velocity does not. Then C5, it does not end with 0, so we cannot use C5. And we can only choose among these two, C4 and C6. But C6 does not make a fluid motion curve with H3. Looking at the displacement, we cannot connect this curve to H3 because it will not make a fluid curve. So we will use C4. So once we have selected our curves P1, H3, and C4, we will have to make a sketch on how it would look like if we connect it. So the sketch would look something like this. Again, the middle motion does not have to end with 0, but the motion should look the same. So here, it starts from 0, from P1, then it goes down using H3, then it goes back to 0 using C4. Then for the velocity curve, it starts from 0, then ends at 0 also. Then for the acceleration, it's the same thing. As it starts from 0, it ends with 0. So it's a matter of imagining how the curves will look like when joining it against each other. So once we have joined it, it would look something like this. And if we divide it into parts, we will have 3 distinctive parts of the motion, and we will have to delegate it as beta 1, beta 2, and beta 3. So this beta 1, 2, and 3 defines the cam rotation angle. So for every cam rotation, how much angle did the cam had? So that's the second part. Calculate the interval of each motion by matching the values of their velocities and acceleration. So given here, the total lift is 70. Meaning, if the maximum lift for harmonic and cycloidal is 35 mm each, meaning we can only use 70 on 8 degree or the first motion on the 8 power polynomial. Then for the formulas that we will use on harmonic and cycloidal, we can only use L equals 35. But for the 8 power polynomial, we can use L equals 70. We will use L70. Then, we can match the values of velocities and acceleration. Let's just choose among them. I have chosen to use the acceleration at the polynomial and the acceleration at the harmonic. So these formulas will be equated with one another, and we have to assume that theta first here is equal to beta 1. Then we have to assume that theta here is 0. So here theta is 0 because the harmonic acceleration ends with 0. So this is that one. So again, the lift is 35 mm only for the harmonic and cycloidal motion, while the lift for polynomial or 8 power polynomial is 70 mm. So let's just substitute the values. For the formula, if theta is equal to b1, this is cancelled into 1. Number 1, 1, 1, and 1. Then beta 1 will be this L over beta 1 multiplied by this value will be equated to the acceleration formula of harmonic, where theta is equal to 0, meaning this will be cosine 0. Then we will be left with beta 2. So when this is equated here, we will have a simplified relationship of beta 2 is equal to this value multiplied by beta 1. Then we have to make, since we have three variables, beta 1, beta 2, and beta 3, we have to make three equations or three relationships. We already have two. The first one is beta 1, beta 2, beta 3 equals 360. The second one is this one, beta 2 is equal to beta 1. Then another one, we can match the velocities as at H3 and C4. Again, we can match velocities of polynomial and harmonic, polynomial and cycloidal. But for this one, I used the matching the velocities of H3 and C4. Again, for theta and beta 2, we can assume it equal. This is only for the computation of this one. Then for theta is 0 because again, the velocity here ends with 0. Then both the lift is 35 mm because we will be using harmonic and cycloidal, and in the given problem, there is only 35 mm of lift for harmonic and cycloidal. Then we select the formulas from the table of the Klomuk and Mafli. Again, theta and B2 it can be cancelled into 1 because they are assumed equal. Then this will be cosine 0. And we will now have a relationship of this one. Beta 3 is equal to 4 over pi beta 2. Then, since we have three unknowns, we have now three equations. We can compute for each. Let's substitute beta 2 here with this one. Let's substitute beta 2 here with this one. And so let's substitute beta 3 here with this one. We will now be able to compute for everything, whereas beta 1 is 171, 82, and 106. Meaning, in this cam displacement curve, the first part, the 8 power polynomial, it takes 171 of cam angle rotation. Then we have 82 of cam angle rotation for harmonic. And for cycloidal, we have 106 cam rotation. Then another ask in the problem is to determine the lift when the cam angle is 90. Meaning, for for the formulas that we will use for theta, we will use 90. First, let's determine at what motion is 90 degrees. We have computed that the 8-degree polynomial is at 171, harmonic as at 82, and cycloidal at 106. Since 90 degrees is still within the 8-degree polynomial motion, we will use the formula for displacement on the P1. So, using formula for displacement at P1, the theta here is 90, the lift is 70, and the beta 1 is 171. Then all will be substituted to this formula, and we will now have the displacement of 33 point something. Then lastly, if given here again, determine the lift when the angle rotation is 270. So where is 270? Again, for 8-degree polynomial, we only have 171. For harmonic, we have 82. And the total of these two is 253. Meaning, at 273, we have cycloidal motion. So the lift formula we will use is from the cycloidal motion. So using the displacement formula at C4, here, theta is 270 minus beta 1 and beta 2. So we have to remove the angle of rotation from the polynomial and the harmonic motion. And beta 3 is equal to 106 as computed earlier. We will just have to substitute everything here in the formulas, and we will have an answer of 24. Again, the formulas are only intimidating because they are long, they have a lot of variables, but again, you will not have to memorize this one. So this is the cam displacement curve analytical method. So using a lot of formulas, using a lot of given, we can determine the cam displacement curve. Okay, so reminders on the schedule. Tomorrow is design plate number 3. So we'll have to bring again the formulas. I will upload later the design consideration. Then next week is lecture on gears. The following is this lecture on the flexible transmitting elements. Then come this gear design plate. Then the following week will be holiday. This November 30, I think, walang pasok. Then December 1 is our design project presentation. So I want you to focus on that because you're already aware of your midterm exam. For the design plates, kasi pag-grade ako ng design plates, very generous ba? So doon ako nakuha ng grade. Kung paano ko kayo mapapataas pa kung sakali. So kaya wag muna kayo maghanap ng grade doon. Kasi pagka na-fix ko na yung grade doon, wala na kayong pagkukunan, di ba? So yun lang for today. See you tomorrow. Thank you for attending Lakas. Yes, Alvin.
Sir, may question lang po about sa design plate number 3. Yan nga po ay bukas din po ipapasa.
Hindi. Di ba, usually naman tayo ay may 1 or 2 weeks. Ano, 2 weeks pang ginibigay ko, 1 week. Kasi sa akin, the best, may pasa mo na agad bukas. Kasi ang dami nyo nang gagawin. Hindi, gagawin ko, ituturo ko lang din naman sa inyo kung paano siya gawin bukas. Pero, kung i-delay nyo pa, matatambakan kayo eh. And, ang sa akin, i-make sure ko lang na meron tayong oras para makakapaggawa kayo on the same day. Para hindi tayo magkakaroon ng dahilan na dami niyong ginagawa, marami kayong ganun. Kasi kaya nga dinedicate ko na yung 3 hours para doon. Kasi within 3 hours, kaya naman gawin yun. So, kayo ba yung sagot ko, Alvin?
Yes po, sir. Thank you po.
Okay. Any more question? Okay, kung wala na is thank you
Sir,
for...
meron pa po. Sir, meron
Yes.
pa po.
Okay.
If dun daw po sa design project, if okay lang daw pong sa SolidWorks gawin.
Sa SolidWorks naman talaga siya gagawin. Sinabi ko nung nag-orient ako, di ba?
Okay po. Thank you po. Tinatanong lang po.
Okay. Okay. See you bukas. Ingat.
Thank you po.
Thank you, sir. See you tomorrow. Thank you po, sir.
Thank you.